All right, can you guys hear me okay? Say yes or not. I'm really excited to be here, and thanks to the organizer for having me. I haven't done much talks before, so I was really glad to get that acceptance email to be here. Really excited. So I hope that I won't disappoint you with this talk. It's titled Database Technologies for Offline First Apps, and I have to admit that I didn't put a lot of thought into this title. It sounds kind of academic, kind of boring. So I came up with a new title. That's much better. And here's a picture of me sitting on the surface of Mars. And you can see I'm satisfied because I'm using my app and it works on Mars. All right, but let's get serious. There's other use cases for offline first besides space travel. Some of them will be resolved when we have internet everywhere, but I believe that some use cases will remain relevant. For example, taking an offline retreat where you just want to disconnect from all the madness. But first, let me kind of introduce myself. So right now, I'm a co-founder at a company called Reflect. And we're building a note-taking app. It's end-to-end encrypted, and it is the same model as Obsidian or Roam that you may have used. You can tell that a note-taking app is a perfect candidate for building offline first. The rest of my life has been kind of a typical web developer, with one exception. I've spent some time building native apps for iOS and Mac. And I kind of fell in love with native apps. If you look at something like Things, you can tell that it's like the perfect app. It looks beautiful. It is using the system resources perfectly. It even has the right animations. They're not too subtle and not too annoying. And I was wondering, is there an Electron app with that level of polish? I was thinking about this, and one day I downloaded an app called Quill. This was a Slack competitor. And when I saw that app, I thought it was beautiful. You can notice a bunch of little details that make it look like native. The sidebar is transparent. It's using the components that look just like native components. The colors match the system scheme perfectly. Even the animations and the sound effects make it look like a native app. Sadly, it got acquired by Twitter, so it's dead to me now. But Quill passed the Turing test for me. What I mean by that is when I downloaded it, I thought it was a native app. And one reason for that is they don't use Electron, but like a custom tooling, which made the app really slow, and it doesn't use a lot of RAM. So anyway, I got really excited about building Electron just then. I thought it might just be possible to build Electron apps that look and work just like native. And Reflect is like an attempt to do that. If you want to try the app, you can tell me if it passes the test for you, although I just spoiled it. It's an Electron app. Anyway, what does it take to pass this Turing test? What does it take to fool people into thinking it's like this perfect native app? In my opinion, the first thing to do is to optimize your speed. And Superhuman has been talking about this quite a lot. I think it started off with a 100 millisecond rule, and now it's like 32. It's probably going to be like 2 milliseconds tomorrow, but that's okay. I think a way to achieve really good responsiveness in an app is to build offline first, or at least have some offline capability. And there's multiple levels to offline support. To me, let me go back one slide actually. To me, offline first is the pinnacle of this offline support. When you do offline first, it means you can download a DMG file, you can just drag it into applications, you can open the app, and you can start using it. And then, if you choose to do so, you can go into preferences, and you can set up some kind of synchronization. That would be ideal, in my opinion. There's other reasons, and you may have read this essay about offline first, and I've already went through some of these reasons. So there's speed. There's the fact that the network is optional. You can use it while you're offline. Also, there's the fact that the data stays on your machine And the whole cloud thing is something you can opt into, but it's not necessary to use your app. However, my favorite reason to build offline first is ease of development. It feels like we're back in 2009 and using Rails to build apps. It's like you can start on a Friday and have a working application by Sunday. And I think the reason why offline first can be rapid prototyping is that, before like SPAs, the model looked something like this. Everything was happening on the server, and now we have the SPAs, and things are kind of happening on both sides. You have to write code on both sides. You have some kind of database on both sides, and you have to debug on both sides. With offline first, what I'm thinking is we're going to do all the work on the client side. And there's still going to be replication and a server, but that's not our problem. We're going to let some library or some service take care of that. We'll only be working on the client. And the thing is, native apps have been offline first for not years, but decades. And it makes sense. They started out offline first, and then they added sync on top of that. So why is it so hard in web apps? And to answer that question, I'm going to look into the architecture of an offline first app, or just maybe any app. So you start with user interface, and it's talking to some kind of database. The database needs to be persisted, and it needs to be synced with the server. I could add another step here. You're not talking directly to database. You're like talking to stuff in your memory, and stuff in the memory is queried from database. And luckily, part of this is resolved by using React or other framework. So we have that going for us. Unfortunately, the rest of it is kind of a question mark. There's no standard solution to this problem. So Apple folks, they're quite lucky because they have this framework called Core Data and a service, I think it's called CloudKit. Basically, it means they build offline first, then they push a button, and they get synced for free. For JavaScript, it's a little more complicated. There's quite a few options to choose from. So I prepared a couple questions to ask yourself when you're about to build your offline first app and you're picking these technologies, these databases or services. Here are a few things to consider. First, is it modular? So if you think about Firebase, that's an all-in-one solution. And I would advocate against all-in-one solutions because none of the current all-in-one solutions are very good for offline first. Firebase is not great for offline first. It's kind of okay on mobile devices, but on the web, not so great. And I think if you compose from multiple components, you get to pick the best database, you get to pick the best server, you get to pick the best syncing engine. Yeah, already said that. Is it reactive? So basically, if you decide to use something like SQLite in your web app, it won't be reactive, which means if you make queries to it, they will not automatically update. Luckily, there are libraries that will add reactivity on top of SQLite. I'll get to that. Another thing to consider is, will it play well with your code? There's one library that I kind of like. It's called RxDB, but it depends on this framework called RxJS. You may be using it, but like my whole app is built with different technologies, so that wouldn't work for me quite well. I'm a big fan of MobX, so when I'm choosing this library, I will make sure that it can play with my favorite framework nicely. Very important question is, how does it replicate data? So if you're not familiar, replication is just like a fancy term for synchronization. So one question is, do you get to bring your own backend, or does it provide a backend for you? From these frameworks, I think Firebase is the only one that provides a backend, but I think that'll change soon. And then there's the question of conflict resolution. So Reflect app, our note-taking app, is, it's a text editor. So conflict resolution is a very complicated problem, and we kind of had to roll it out ourselves. And it would be kind of ideal if we had a library that would support that out of the box, even though I'm being too idealistic here. Okay, how does it persist the data? You have to kind of ask, how big of a database will it support in your web app? So there's going to be a big difference between some small to-do app and like a whole accounting app, for example. Then you have to ask, kind of related to previous question, does it perform well? So again, if you're building something simple, it takes 1 or 2 queries to render your screen. But if you're building something quite complicated, you will need that performance. IndexedDB, I'm looking at you. Okay, how to query the data. So some apps will require building pretty complex queries. I mentioned the example of accounting app or like some financial app. An app like that might be rendering a chart, and getting that chart might require crunching thousands of records. If your database doesn't support like SQL or slightly more complicated queries, you're going to have a hard time preparing data for that chart. Another feature is indexes, which makes querying and filtering faster, and it can give you search functionality for free. And then, of course, is it really offline first, or is it just offline capable? I think Firebase and Replicache, I'll talk more about the Replicache, but I think these two kind of look like they're offline first, but they're not really. Because if you take them offline for a couple of days, they aggregate changes on your client, and eventually they'll slow down. So in my ideal world, I want a solution that will work even if I don't use cloud at all. Again, maybe I'm asking for too much. And this is a fun part. So most people would think that I can just wrap my app as Electron app, and there's no need to worry about windows or tabs or things like that. But I think it's really good for native apps to support windows and tabs. So I think it's really good when you're choosing this technology. I think it's really good to keep that in mind. Is that going to be an easy thing to do? Typically, you would make a change in a tab, and that would be saved in a database, and somehow those changes should propagate in the second tab. So if you're building a native app, that's really easy, because your entire app is sharing the memory. So each window and each tab is talking to the same memory, which means you can have an object and just like observe changes on that object and update your UI. The problem with browsers and with Electron is that every tab or window is a separate process, which has separate memory. So you have to use a little more complicated solution to keep it in sync. The way it kind of used to work before was that you would write to backend from one window and the other would be updated from backend, which is not a good solution for offline first for obvious reasons. So one option to implement is to put your database into a shared worker, and basically your windows will be talking to a separate process or thread, I'm not really sure. Anyway, another option is to have multiple windows, and each window is holding the database code in the memory, and it's sharing the storage between them and having some way of notifying for changes. Broadcast channel is a new API that I think is being used for this. And related to that question is your app going to be sync or async? You would think that it's better to go async, because that's how we're used to things working with web. Like, you make async requests, and we're used to rendering these spinners and loading states. And going async, I think, is a great option if your queries are kind of slow. If your queries take like more than 50 milliseconds, it's good to go async and show some kind of loading state. But if your queries resolve in a few milliseconds, it might be better to go sync. That means you don't have a loading state at all. You click somewhere, and it kind of freezes the UI until the next frame displays your data. However, if you decide to use the worker, like I mentioned, and if you decide to go async, you're going to have to deal with serializing and deserializing messages, which can slow things down. Okay, this is another big question for me, because Reflect has a mobile app that is built on a capacitor. So we've been dealing with this problem before. Basically, you use some kind of framework, you use it in a web app, and this framework might use IndexedDB, for example. And now you want to use the same framework in React Native or capacitor. However, in a mobile app, you don't have to use IndexedDB because you have SQLite available. On mobile platforms like React Native, SQLite has native implementation. So you would end up doing something quite silly. You would build your database on top of IndexedDB, but IndexedDB would be basically polyfilled in your React Native context and actually using SQLite under the hood. This is something to keep in mind, and I think it's better to pick a technology that can switch adapters. RxDB can do this, and I think that one is pretty good at that. And something like Firebase wouldn't even work that way. If you want to use Firebase in React Native, there's like a whole separate package that you use. You don't use the web Firebase in React Native. It's a separate package that's using like Swift code to do the Firebase things. Another question, if you're building like a Swift app, are you getting the same API with your technology of choice? Firebase is the only one that's good at this right now, I guess. But if you're picking a new technology, that's also something to consider. Are you going to build in Swift or Java? And of course, how much it costs. Both Firebase and Replicache are paid. These guys are paid projects. Well, not that important. Cool. So I want to mention. Oh, can you still hear me? Okay. I want to go through possible approaches to building databases for a front end. So one thing that we've been doing for a while is just keeping data in memory. The whole idea is that you skip the whole database part, you just serialize your entire store, and you persist it on disk. There's a few projects that work this way. Tinybase is one that caught my attention. It seemed to have quite a lot of features, database-like features like indexes, querying, all that stuff. And RxDB has switchable adapters, so it can be used in memory and other ways too. Obviously, the great thing about in-memory is that it's extremely fast. However, you have to serialize the entire store, and that can be kind of slow. Now, IndexedDB. All right, so IndexedDB, I think my favorite way to use IndexedDB is through Dexy.js. That's a pretty cool library. RxDB also has an adapter, or you can just use it straight. But IndexedDB has quite a few problems, speed being the first problem. It's fine for a very simple app, but as soon as you're making multiple queries, it gets slow, and it's kind of unreliable. So for example, Safari will wipe your data after a week if you don't use the app. So we have two choices, putting everything in memory or using IndexedDB. And I want to mention some other solutions. So one particularly smart solution, in my opinion, is combining in-memory and IndexedDB. So Replicache is the project that does this. Basically, your database gets loaded in the memory, you use it, it's very fast because it's in memory, and then it's persisted. And it's persisted in a really smart way. It's only saving the stuff that changed, and also when it's being loaded, it's only loading what is needed for your current request. They also have like a really nice algorithm which is putting multiple objects into a single IndexedDB row. So in this case, they're putting like 50 objects in one row. Basically, they did a really good job at getting the best out of IndexedDB. However, Replicache is not offline first, but if you look at their roadmap, it looks like it's going to be. So this is really good news. We would have like a proper offline first framework. And they're also going to add, I think, a cloud. So it might become a really good Firebase competitor. We'll see how that goes. So Replicache is becoming sort of an all-in-one solution. But like I said, that might not be ideal. Just in case you decide to use SQLite instead of IndexedDB, you will kind of have a pretty hard time still using Replicache. And finally, the favorite part is running SQLite in the browser with WebAssembly. And this is kind of new. Well, it's not really new, but some things about it are new. So there's a few libraries that do this. The first one is called SQL.js. It's just SQLite in the browser. The only problem with this library is that it doesn't support any persistence. So I don't think it would be very useful for building offline first app because you can't really persist your database. Kind of recent library is called AbsurdSQL. And that's a really smart idea. It's powering an actual app called Actual Budget. And remember, like I mentioned, the accounting application, the finance example, this is exactly it. There's a whole article about it, but they were trying to use IndexedDB, and they hit the limitations of that fairly early for a complicated app like that. So they built a whole database, more like storage for SQLite. So AbsurdSQL is basically SQLite running in the browser, and is using IndexedDB as the file system. So that means when SQLite wants to save files, it doesn't save them into a file. It gets saved as binary data into IndexedDB. It's a smart idea, kind of absurd, and it's in the title. There's a new API now called Origin Private File System, which aims to resolve this exact problem that Absurd SQL solves. So basically, you're running your JavaScript code, and it needs some kind of persistent storage. Origin Private File System will create a storage for your website, for your app, and when you write something to it, you can be sure that it'll still be there a week later. So the idea is that you run SQL in WebAssembly, and it'll be storing its files in this private file system. So we have 3 options for SQLite storage. Well, the first one is not really an option. We have 2 options for SQLite storage. So right now, file system in IndexedDB is your best choice because the OPFS isn't supported by all browsers yet. I think it's only supported by Chrome and like Microsoft Edge, but the other browsers will support it sometime this year, hopefully. So eventually, this will be a great option for SQLite in the browser. And there's these few libraries that I mentioned, and one of them is supporting both of these ways of storing data. It's called WA SQLite, and I think this is a really interesting project to follow. Cool. So we have SQLite running in browser. What do we do now? Well, we need to have some kind of framework for working with our data. We're not going to write plain SQL. There actually are projects that do that, like write SQL directly in React components, and it could be a way to do it. However, you could also use one of these existing projects like RxDB or WatermelonDB. These projects were originally made for React Native. So they work really well with SQLite, and then they added like in-memory persistence as a workaround to work in web apps. But they're made for SQLite. So you could just use this project against SQLite running in the browser. And at the end, I want to mention just some projects to check out that I didn't really dig very deep into them, but VLCN promises to build some useful stuff on top of SQLite in browser. One of them is reactivity. So you can just write some reactive queries, and your UI will get updated when the data changes. And the other thing is they're building CRDTs, so that's just conflict resolution, and they're building it as extension to SQLite. So it's kind of complicated approach, but I think this is well worth looking into and playing with. And another project is very recent, and I just discovered it a couple days ago, but I think this one is really worth looking into. It promises a lot of features on top of SQLite running in the browser. And it's meant for local first apps. So this is another one to look into. And with that, I think that's all that I have. I was trying to make it within 25 minutes, so I hope I did a good job. And thank you very much for having me.